children, welcome to Right Tuition Classes. We're going to do chapter 1, force. Okay, here I'm going to help you understand the concept. Okay, and get my words very clearly. Okay, children, we start with it. Like, what do you mean by a force, children? In your 9th standard, you learn what do you mean by a force. So you said force is that physical quantity. I'll just define it for you. Force is that physical quantity, beta, which changes or tends to change the state of rest or state of motion of a body. Force is what? That physical cause. I can call it as that physical cause. See, these are not, I'm just writing to help you understand, okay? Force is what, beta? That physical cause which changes or tends to change the state of rest or uniform motion. Okay, I'll use the word motion, okay, of a body. Okay, please keep it in mind. So force is that physical cause which changes or tends to change the state of rest or motion of a body. Got it? Now, you should know the meaning of this force, okay, children? Now, force is also defined as rate of change of momentum, okay? Force is also defined as rate of change of momentum, okay? Now, we go ahead, okay, one step ahead, okay? To understand the next chapter, we first try to understand what do you mean by rigid body, beta. We'll come across the word rigid body in the beginning. You should know everything, you should never have doubt in your mind. You should know the meaning of every word. What do you mean by rigid body? See, rigid bodies are the bodies, okay, are the bodies where the spacing between the interparticles, this rigid body is made up of some particles. So interspacing between the particles is very less. Got it? As a result, they exert a very strong force of attraction on each other. So these particles, they do not have a free motion. They only vibrate in their mean position. So a rigid body, because of this, has a definite shape. Got it? So remember, what do you mean by a rigid body? Bodies, please keep in your mind, where interspacing between the particles, between the particles and molecules, you can say between the particles, okay? Between the particles interspacing between the particles is very small, very small. Hence they exert a very strong force of attraction on each other. Hence, please hear, hence on each other. Okay, which prevents them from having free motion, these particles, okay, they cannot move freely. I'm talking about the particles, children. These particles, they do not have a free motion, prevents them from having free motion, okay? They only vibrate in their mean position, okay? We talk this, we call, got it, in the mean position. Hence, they have a definite shape. So बच्चे लोग देखो, समझने की कोशिश करो बेटा. मैंने पहला फोर्स का मतलब समझाया. What do you mean by force, बेटा? A force is that physical cause which changes or tends to change the state of rest or state of motion of a body. Got it? You can also define force as a rate of change of momentum. Got it? Now, the next word, what I'm trying to tell you, is rigid body. Now, what do you mean by rigid body? The bodies where interspacing between the particles is very particles between the particles is very less, very small. Hence, they exert a very strong force of attraction on each other. And this prevents the particles from having a free motion. So they only vibrate in their mean position. Hence, these particles have definite shape, children. Now, I told you what is the meaning of force and what is the meaning of rigid particles. Now, what I'm trying to tell you, I'm going to tell you this, I'm continuing with this rigid particle. I'll see like this, one rigid particle I've got, rigid particle which is a rigid body, I'll say, I've got one rigid body, children. I've got a rigid body which is free to move, rigid body which is free to move, which is free to move, okay? Free to move. You have a rigid body which is free to move. And another one, another rigid body, better, another rigid body, which is rigid body, which is pivoted at a point, okay? Fixed at a point, pivoted at a point, okay? Fixed at a point. So you have a rigid body which is free to move. You have another rigid body, okay, which is pivoted at a point, okay? Now, when you apply a force to this rigid body, which is free to move, the body moves in the direction of the force, the body moves in the direction of the force, okay? Direction of the force, okay? Whereas, please here, we call this motion of the body, I call it as motion of a body, I call it as a translational motion. Body is called what? Translational motion is called translational motion, because motion of a body along a straight line or along a curve, we call it as translational motion. So here, this body was free to move. You can see here, this body was free to move. The rigid body was free to move. So what you did, beta, you applied a force on this rigid body. When you apply a force on this rigid body, the body moves in the direction of the force. The body moves in the direction of the force, children. Got it? And such a motion of a body, we call it as translational motion. Now look here, another body which is pivoted at a point. Okay, you can see this body is pivoted at a point, okay? Now, you apply force on this body, beta. But this force, if you apply it anywhere, nahi chalega, beta. You have to apply in such a way, please, in a particular, please, you are trying to understand, you have to apply this force, got it, at a suitable point. When you apply force at a suitable point, beta, then only this rigid body, it doesn't move, got it, but it tends to move about an axis of rotation passing through the point of pivot. Now, such a motion of a body, I call it as a rotational motion. Now, why am I taking such a long time? I could have gone fast, but I said, this is what we are interested in. Now, I apply a force on this body, beta. Another rigid body is pivoted at a point. You apply a force on this rigid body. What happens, beta? This body doesn't change, doesn't move at all. It doesn't move, doesn't get any translation motion. Why? Because it is pivoted at a point. Got it? This body does not change or does not move along a straight line, along a straight line. Got it? But see, you apply a force on another rigid body which is pivoted at a point. This body does not move along a straight line, beta. But what happens? You apply a force at a suitable point, okay? So that suitable point, but the force applied at a suitable point, force applied at a suitable point can bring out a rotational motion about an axis, passing through point of pivot, okay? Now this is, again, children, I have a rigid body which is free to move, and I also have another rigid body which is pivoted at a point, okay, Now force is applied on a rigid body which is free to move. So what happens to this body, beta? This body moves in the direction of the force. Now the motion of a body, such a motion of a body, we call it as a translational motion. Now, you apply the force on another rigid body which is pivoted at a point. Now, this body does not move along a straight line, doesn't move only. But the force applied at a suitable point, okay, can bring out a rotational motion about an axis passing through a point of pivot. Got it? So this force, what it does, a force applied at a suitable point on this body can bring out a rotational motion about an axis passing to the point of pivot. So this is because of the force. So I can call this as a turning effect of the force. What I can call it? A turning effect of a force. Are you getting me a bit? So remember, a force applied on a rigid body pivoted at a point and at a suitable position, okay, suitable point, it can bring out a turning effect in that body. Are you getting me here? We call this motion as rotational motion. Keep it in mind, okay? Now I'm just going to talk about this turning effect of the motion of a body, okay? So I hope everybody understood me here. We go ahead, children, to the next, okay? Now, what I tell you is, suppose you moment of force. Now, I'm going to tell you a new word called moment of force. What do you mean by moment of force? Okay, moment of force क्या है? Force नहीं है बेटा. Moment of force क्या है? आपको देखना है इधर. Try to understand what do you mean by this moment of force. Okay, this moment of force. I'm using the word moment of force, but what do you mean by this moment of force? Got it? So listen. Suppose any rigid body is here. Okay, I'll tell you this rigid body is pivoted at a point P. Got it? And you apply a force along this line. Got it? You apply a force along this line. Okay, your force is here. You apply a force along this line. Now, when you apply a force along this line, what happens, beta? This body doesn't leave its place and moves along a straight line. But since it's pivoted at a point, it tends to move. It tends to move like this. It tends to move. Can you see along this arrow? Got it? So what has happened? This force has brought a rotational motion in the body. We call this as a turning effect of the body. We call it as a turning effect of the body. Now, this turning effect, it depends upon two factors. Got it? So, these factors, please have a look here. Factors affecting factors affecting the turning of a body. Turning of a body. Please have a look at factors affecting the turning of a body. Now, there are two factors, okay, which affect the turning of the body. Now, what are those two factors, Beta? First one, I'll say it depends upon the magnitude of the force, the magnitude of the force, the magnitude of the force applied, the magnitude of the force applied, magnitude of the force applied, okay? And the second one, I can also call it as the distance of the line of action of force, distance of line of action of force, line of action of distance of the line of action of force from the axis of rotation, from the axis of rotation, okay? So once again, I repeat, children, factors affecting the turning effect of the body. One, I'll say the magnitude of the force, okay? Suppose this body is here, and this is a line of action of the force. This is a line of action of the force, okay? This is a line of action of the force. This is a line of action of the force. Now, this is the perpendicular distance, okay? This is the distance of this force. Like suppose PM, if I draw, this PM is the distance of the line of action of force from the axis of rotation. Got it? So the turning effect, it depends upon the magnitude of force there. It also depends upon this distance PM, distance of the line of action of force from the axis of rotation. Got it? So it was found that if F is more, okay, big value of F, and the value of pH is small, okay, this is a distance, PM is small, still they found out the turning effect was large, okay, it moved, okay. I repeat better once again, try to understand that if F was big, but this distance PM was less, so the turning effect, F was big, okay, PM is small, the turning effect was large, okay. Now, if I say, array, but if F is small and this distance was more, still the turning effect was large. So turning effect depends upon both. If F is large, PM is less. PM is the distance. The distance is less, force is more. Turning effect was more. If force is less, distance is more. Turning effect was more. So whenever a physical quantity depends upon such two factors. If one is big, other one is small, still the physical quantity is more. Or if one is small, the other one is big, still the physical quantity is more. Either way, correct? The physical quantity is going to be more. Okay. So we say, then that physical quantity can be measured as a product of the two. So turning effect can be measured. This turning effect, I want to measure this turning effect. This turning effect can be measured as F into PM, correct? I hope people are understanding. Suppose I'll give you a mathematical example. Please have a look here. I want 51 as an answer. So two numbers are multiplied and I want 51 as an answer. This is the first number. This is the second number. Okay, these two are multiplied. See, the first number is very big and the second number is small. Still you get 51. Or first number is small and the second number is big. Still you can get 51. Are you getting me here? That is what I want to tell you. The turning if F into PM, okay? If F is more, PM is less, turning effect is more. If F is small, PM is more, still the turning effect is more. So turning effect depends upon both of them. Got it? So such physical quantity, relation of a physical quantity depends on two things. If one is more, the other one is small, still the physical quantity is more. If one is less and the other one is big, still the physical quantity is more. So either way, the physical quantity is going to be more. So I say that physical quantity can be defined as a product of the two. So here, turning effect can be defined as a turning effect can be said as a product of force and the perpendicular distance of the force from the line, perpendicular distance of the line of action of force from the axis of rotation. Now, this product is called, I will not call it as turning effect, but I better give a name for it, and that is what? Moment of force. That is what? Moment of force. What it is? Moment of force. We don't call it as a turning effect. We call it as a moment of force. So moment of force is defined as product of magnitude of force and its distance from the axis of rotation. Are you getting me, children? So remember, this other name for this moment of force is torque. Other name for this moment of force is torque. Are you getting me here? So remember, children, I was talking about, once again, I'll just repeat, go through it fast. Factors affecting the turning of a body. The turning effect of a body. This turning effect of a body depends upon what factors? So I say first, the magnitude of force applied. And the second one, the distance of the line of action of the force from the axis of rotation. Now, if you ask me how, I'll show you some examples, okay? See here, suppose if you take a door, okay? You take a door of ours, okay? You know our door, okay? Suppose this is the hinges and this is the door, okay? This is the door. Now, this door, okay, I can apply a force. This is the door, okay? Remember, this is the door. I can apply, these are the hinges. The hinges of the door are here. These are the hinges of the door, okay? So this is the line of axis of rotation of the door, okay? Hinges. So when you apply a force here, you apply a normal force on the door here. Normal, okay? Door khada hai, seedha, perpendicular. You apply force on this, okay? So the whole door gets opened up. This force was less, but since this force was at the maximum distance, got it? Door ka bahar to nahi ja sakta. So you saw the door opened up. Got it? That opened up पूरा. तो अगर इधर आपने अप्लाई किया, तो इधर जब अप्लाई किया आपको छोटा फोर्स लगाना पड़ा, द डिस्टेंस वाज मोर. लेकिन अगर आपने ये पॉइंट में फोर्स अप्लाई करने को जाएंगे, ओके, खोलने के लिए, तो आपको बहुत बड़ा फोर्स अप्लाई करना पड़ेगा, बिकॉज एक डिस्टेंस कम हो गया, लेकिन खुलेगा, पूरा दरवाजा खुलेगा. आर यू गेटिंग मी? सो दैट इज व्हाट आई वांट टू टेल यू. ओके, if the magnitude of force is large, got it, and the distance small, still you get the turning effect, okay, same turning effect. Or if you increase the distance and make the force smaller, still you get the same turning effect. So turning effect, I can say, depends on both magnitude of force applied and the distance of line of action of force from the axis of rotation. This turning effect, okay, can be defined as product of force and the distance of the line of action of force from the axis of rotation. But instead of calling this turning effect, I give a name, I call it as moment of force or torque. So what is moment of force? Moment of force is defined as a product of force and its distance from the axis of rotation. Are you getting me, children? So moment of force is defined as, let's go ahead, okay, what do you mean by moment of force? Now, once again, what do you mean by moment of force? So moment of force is or you can also call it as torque, okay, you can also call it as torque. It's one and the same. Is defined as product of, product matlab multiplication, product of force and the distance of the line of action of force and the distance of the line of action of force, from the line of action of force from the axis of rotation, okay, children. Okay, so I can say, okay, here moment of force equal moment of force equal, we just call it as force into distance. What is this, beta? This distance is nothing but distance of the line of action of force from the axis of rotation. Now, why did I give you this formula? So that now I'm going to tell you the SI unit, okay? What is the SI unit? Please have a look here. This SI unit of force is Newton and SI unit of distance is meter. So it becomes Newton meter. Okay, CGS unit, okay, is, please keep it in mind, this is dyne, okay, into centimeter. So it can become dyne centimeter, got it? Now, remember, it could have been also in gravitational units, okay? What is gravitational units? I'll tell you. This can be kgf into meter. So it can be kgf meter, got it? Or it can be, please here, gf into centimeter. It can be gf centimeter, got it, children? All these are the different units of moment of force, children. Now, when you see, children, earlier, one more thing you can see. This Newton into meter, you come across this unit in for one of the physical quantities. What is that? Try to recollect. Now, if you ask me, beta, work is nothing but force into displacement. So it can be Newton into meter. This work, okay? And this work unit is called a joule, okay? What it is called, beta? Joule. Sorry, small letter, joule, okay? It is called a joule. Now, this Newton meter, yeah, moment of force का Newton meter को you cannot give this name. वर्क को दे सकते हैं, न्यूटन मीटर इज फोर्स, बट यू कैन नॉट कॉल movement of force को the same Newton meter here, but you cannot call it as joule. Now, what's the reason behind it? Simple. This movement of force is a vector quantity. This movement of force is a vector quantity, whereas work was a scalar quantity. So this joule was a unit of a scalar quantity, whereas movement of force is a vector quantity. It has a direction also, and that's a reason joule you cannot give for this Newton meter. It has to be Newton meter only. Okay, children, they can always ask you these questions, okay, in the form of fill in the blanks. Okay, now after knowing this moment of force, I tell you, children, the rotation is possible in two different ways, okay? Any body you want to rotate it, there are two possible rotation. Can you see? If a body has to rotate, children, if a body has to rotate, दो possible rotation हो सकता है. Suppose I'll just tell you, children. Suppose this is a wheel, okay? It's pivoted at this point, okay? I can apply a force here. When I apply a force, in what direction? You can see this is called, this direction is called clockwise direction. So I apply a force in this direction. So the rotation produced is clockwise. Produced rotation produced is clockwise. Rotation produces clockwise. Okay, beta. Rotation produces clockwise. Okay, on top I shown you the direction. Okay, this called clockwise rotation. Okay, जैसा घड़ी में कांटा जो घूमता है ये डायरेक्शन में घूमता है, इसके लिए इसको clockwise rotation बोलता है. So this body, it tends to move, rotates about clockwise. Rotation produces clockwise. Hence, this movement of force is called a clockwise movement. Movement of force is called a clockwise movement. Is called clockwise movement. Clockwise movement. And please keep it in mind, children, from the notation point of view, notation, it is negative, okay? It is negative, okay? It is, and notation like, it is taken as negative or conventionally, notation like conventionally, it is taken as, okay, conventionally, okay? It is taken as negative. So अभी से If there is a negative movement of force, remember the rotation is taking place clockwise. Are you getting me, children? Okay, clockwise is negative. Most angles ka measurement may be when an angle is measured clockwise, it's negative, whereas angle is measured anti-clockwise, it is positive. The same applies here also. Okay, so now if the rotation, suppose you apply a force on a body, okay, and I'll put it like this, I apply a force on the body. Okay, this is the body, beta. We apply a force on this body, and now when I apply a force on this body like this, okay, now this rotation takes place like this, beta. This rotation is called anti-clockwise rotation. Rotation is produced anti-clockwise. Rotation produced is anti-clockwise. Rotation produces anti-clockwise. Okay, rotation produces anti-clockwise, and this movement of force is called clockwise, anti-clockwise movement, anti-clockwise movement. Okay, and conventionally, matlab when you solve sums up करेंगे, conventionally it is taken positive. It is taken as positive. It is taken as positive. So you should know this. Okay. So I hope people are understanding me. I repeat, beta. Please have a look here. I'm talking about. Okay. I'm talking about. Okay. Remember, what I'm saying is here. This movement of force can be what you can say clockwise, a movement of force can be anti-clockwise. What are they? Let's see here. When the rotation produces clockwise, rotation produced by a force is clockwise. Rotation produced by a force is clockwise. Then the movement of force is called clockwise movement. And conventionally, it is taken negative. Now, rotation produces anti-clockwise. Then rotation produced by force is anti-clockwise. Then the movement of force is called anti-clockwise movement. And conventionally, it is taken as positive. Okay, children. Now, I go to the next part. Okay, so did you understand clockwise movement and anti-clockwise movement? Then one more thing, children. आफ्टर अंडरस्टैंडिंग बेटा इस तरह का रोटेशन को एंटी क्लॉकवाइज बोलते हैं और इस तरह का रोटेशन को क्लॉकवाइज बोलते हैं बेटा अगर आपके पास एक स्क्रू दीवार का अंदर है थोड़ा गॉट इट अभी ये स्क्रू को अगर आपने एंटी क्लॉकवाइज घुमाया तो ये स्क्रू बाहर आएगा बेटा इट विल कम आउट ओके और ये स्क्रू को अगर आपने इसको एंटी क्लॉकवाइज घुमाया इसको क्लॉकवाइज घुमाया तो ये अंदर जाएगा ओके सो नाउ व्हाई डिड आई से ये स्क्रू जस्ट इमेजिन एक स्क्रू है इस स्क्रू को अगर आपने क्लॉकवाइज घुमाया आप पेन को क्लॉकवाइज घुमा रहे हो गॉट इट तो क्या होगा बेटा स्क्रू बाहर आता है स्क्रू बाहर आ रहा है ओके स्क्रू बाहर आ रहा है गॉट इट और अगर उसको आपने क्लॉकवाइज घुमाया तो स्क्रू अंदर जाएगा अभी मैंने क्यों बताया बेटा देखो याद रखो मैंने बताया मूवमेंट ऑफ फोर्स इज अ वेक्टर क्वांटिटी मूवमेंट ऑफ फोर्स इज अ वेक्टर क्वांटिटी मूवमेंट ऑफ force is a vector quantity. So vector quantities always have direction. Okay, vector quantity. Movement of force is a vector quantity, and movement of force, being a vector quantity, should have a direction. So what is the direction? So please have a look here. When it is turned, movement of force is anti-clockwise. Movement of force is anti-clockwise. Then its direction is along the axis of rotation in a outward direction. Rotation along the axis of rotation, okay, in outwards, matlab coming out, outwards direction. Okay, beta. And now listen, after writing, they say movement of force is a vector quantity. Movement of force is what, beta? A vector quantity. I hope you're understanding me. Movement of force is what? A vector quantity. Since movement of force is a vector quantity, beta, movement of force, one beta, is a vector quantity. Got it? Movement of force is a vector quantity. So when movement of force is anti-clockwise, then its direction is along the axis of rotation in outward direction, coming out. Okay, and if movement of force, if the movement of force, when movement of force is clockwise, children, movement of force is what? Clockwise. Movement of force is clockwise. Then its direction is along axis of rotation, but inwards. Rotation, but inwards. Are you getting me a bit? You should know this, okay? Being vector quantity, you should know the direction, okay? I hope people are understanding me here. Now, I'll just tell you, children, one thing. We come to another small topic. Suppose I say, okay, like, I want to change the direction of rotation. The direction of rotation. Suppose the direction of rotation. It can be clockwise, it can be anti-clockwise, am I right? So the direction of rotation, it depends upon direction of rotation, depends on one point of application. Point of application depends on point of application. Now you'll ask me, what is the meaning of it? देखो बेटा, अगर एक बॉडी है, यही बॉडी को अगर मैंने, ओके, बॉडी है, ओके, और मैंने ये बॉडी को, let's look at this diagram A. If I apply a force, okay, if I apply a force at this point A, got it, in this direction. If I apply a force at this point A, in this direction, it will rotate. It will rotate like this, beta. It will rotate like this, beta. It will rotate like this. Now, what is this rotation? Anti-clockwise rotation. Anti-clockwise rotation. Got it? Now, look at this. See, this is a direction of force. Look at the direction of force. Direction of force is very important. Are you getting me here? Look at the direction of force, okay? Now look at the B diagram, okay? So I say the direction of force is the same. Direction of force, only thing is I'm applying at this point B, but the direction of force is the same. You can see direction of force दोनों में same है, but the application either A में था, either A was your point of application. Here A was a point of application. This is A. And now B is a point of application. So when you apply the force, the direction of force is same in both. But here, abhi aisa घूमेगा beta. This will rotate clockwise. Okay. Earlier, it rotated anti-clockwise. Idhar kya ho gaya? It produced what rotation? You can see anti-clockwise rotation was produced. And here, what rotation is produced? Clockwise rotation is produced. That means the direction of rotation depends upon the point of application. Got it? Point of application किस तरह से है? Okay? अगर point of application नीचे था, look at the direction of force. The point of application ऊपर है, look at the direction of force. Direction of force तो same ही है. लेकिन either when you apply it A, it produces anti-clockwise movement, and when you apply it B, it produces clockwise movement. This is what we see in our car and all, okay? Especially in our car, okay? Our, what you can say, the rim, okay? When you apply, you can, okay? The only changing the direction of forces remain the same, but by changing the point of application, we can change it clockwise and anti-clockwise. Are you getting me here? And secondly, okay, you can also, second one is very simple, beta, like by changing the, what you can say, direction of force, by changing the direction of force, by changing the direction of force, okay? Like at the same point, suppose the body is here. I'll draw it again. Suppose this is your body, this is a figure A, and this is the axis of rotation, beta. Now this is A figure, axis of rotation is here, okay? And suppose you apply a force at this point, okay, in this direction. So when it produces, you can see a anti-clockwise rotation. Got it? But at the same body, okay, the same body, now you apply a force. Okay, you apply a force with the body beta. This is the axis of rotation. You apply a force here in this direction. This is a force. This is a force. Now this produces a clockwise rotation. So only thing, at the same point you applied a force, but the direction of the forces were different. Got it? So you can bring out anti-clockwise movement or clockwise movement depending on the point of application or depending on the direction of force. Either way, I hope people have got me here, children. Now, we go ahead, okay, to some beautiful examples. But before that, very important, children, what I want to tell you before I go ahead with these examples, what I've drawn, okay, luckily I'm not good at drawing, but yeah, with this, especially with this, okay, but anyway, I tried my best, okay, but before I go ahead, remember, moment of force is always equal to, moment of force is given by two things, okay. Moment of force is, you can say force into distance. What I'm saying, force into distance, okay, force into distance. So I'll tell you better. Remember, if force is small, distance is more. Force is small, distance is more. Still, you will get a moment of force. Or the same moment of force can also be obtained, but the force is big and the distance is small. Are you getting me here? So I repeat, moment of force means turning effect. You can produce by applying a small force at a maximum distance from the axis of rotation. Or you can produce the same moment of force by applying a bigger force at a smaller distance from the axis of rotation. So physics का हिसाब से which is an advantage? So always, definitely, when you apply a small force, it's an advantage, if they're not a bigger force. But only smaller forces welcome. So listen here. So what happened? Moment of force is equal to, what is this? See the door, the door. I'll give an example. The first example, what I'm trying to tell you is the handle of the door is always at a maximum distance from the hinges of the door. Is always fitted at a maximum distance from the, what you can say, from the hinges of the door. Okay, it's at maximum distance. You see here what happens. So I'll just put it like this. Moment of force is equal to force into perpendicular distance from the axis of rotation. Okay, so as the distance, when the handle is fixed at the maximum distance from the axis of rotation, then a smaller force had to apply on the handle to bring out the turning effect. Are you understanding? Hence, the handle of the door is at a maximum distance from the hinges. See, moment of force is equal to force into perpendicular distance. Hence, by applying force, smaller force at a maximum distance, a turning effect, a sufficient large turning effect, large turning effect can be produced, turning effect can be produced, okay? Hence, so always remember this is a better. Moment of force is force into perpendicular distance from the axis of rotation. Hence, by applying a smaller force at a maximum distance, a larger turning effect can be produced. Hence, the you can say, I'll write it here. Hence, the handle of the door is always at the maximum distance from the axis of rotation. Got it, children? Okay, same way. Suppose this is, we can call it as hand floor grinder. We call it as hand floor grinder. नीचे एक राउंड ग्राइंडिंग स्टोन है, उसके ऊपर और एक ग्राइंडिंग स्टोन सेम साइज का रहता है बेटा, और बीच में दोनों का बीच में एक होल है, आयरन होल है. गॉट इट? ये जो नीचे वाला स्टोन है आयरन हो, ये जो आयरन रॉड है, बीच में एक आयरन रॉड है, ये जो नीचे वाला स्टोन है ना आयरन रॉड में फिक्स्ड है बेटा, फिक्स्ड है. गॉट इट? तो ये नीचे वाला स्टोन कैन नेवर मूव. The stone which is down can never move. Got it? Now the upper stone, the whole of the upper stone is little bigger than this iron pivot. Okay? Now the handle, please have a look here. You'll always see this upper circular stone of the hand floor grinder is always provided with a handle near its rim, The upper, the upper circular stone, upper circular stone of a hand floor grinder, is always provided with a handle, near its rim, so that, okay, hence it is the force is applied at the maximum distance, hence a small force applied at a maximum distance, from the axis of rotation can produce a sufficiently large turning effect. So yaad rakho beta, I'm trying to put it in very simple words. The upper circular stone of a hand floor grinder is always provided with a handle near its rim. ये question ऐसे आएगा. So why? Because hence, if a small force is applied at a maximum distance from the axis of rotation, it can produce a sufficiently large turning effect. Are you getting me here? Got it? Turning effect on the stone. Okay, so that is the reason always this handle is fitted at a max and near the rim, because that is the maximum distance from the axis of rotation. Got it? The next one, when you look at it, there are some more examples that I'll just tell you. Hope it is clear to you all. Okay, now the third example, what I'm going to tell you is, for turning a steering wheel, you always apply a force tangentially on the rim of the steering wheel. Okay, a force is always applied tangentially. A force is always applied tangentially on the rim on the rim of a steering wheel, wheel of a motor car. Motor car. Now why? That's because, see, a force is always applied tangentially on the rim of the steering wheel of a motor car, so that a small force at maximum distance from the axis of rotation can produce a sufficiently large turning effect, and also okay, but this is okay. Now we go to the next one. Got it? So in a bicycle, in a bicycle, to turn the wheel, to turn the rear wheel, a force is to turn the tire wheel, a force is applied, the force is applied on a pedal, fitted to a large toothed wheel below the, in a bicycle, to turn the rear wheel, a force is applied on a pedal fitted to a large toothed wheel, got it, below the cycle seat. So one, it is convenient to apply force, by the legs in a downward direction, and second, most important, it's more important than this, okay, is, okay, more important than this, in a bicycle, to turn the rear wheel of this bicycle, a force is applied on a pedal fitted to a large toothed wheel below the cycle seat. Now, one point, there are two reasons for it. One reason is it is convenient to apply force by the legs in a downward direction. And secondly, as a large toothed wheel is fitted at a maximum distance from the rear wheel, hence by applying a smaller force on it, a large turning effect is produced on the rear wheel. Okay, now the last of this example, if you ask me about one more example, which is very nice, children, which you should know, that is about a screwdriver. Okay, you can imagine a spanner. Okay, any spanner. What is a spanner, children? You know, children, spanners are used to open the nut. Okay, now any spanner, I'll just draw it. Okay, you can see this is a spanner, beta. The spanner is used to either okay, it is either used to tighten or loosen a nut. It is used to, and naturally what you see, the nut is fixed here somewhere, okay, and you hold the handle here, you hold it here. You try to hold the end of the spanner. So you can see the handle of the spanner is quite long. Now, why the handle is quite long, okay? So listen here. A spanner is used to tighten or loosen a nut. Got it? And it has a long handle to produce a large movement of force by applying a small force. Got it? Normally at the end of the handle. This handle is large enough. Okay. See, a spanner is produced always has a large, has a long handle, has a long handle. A spanner always has a long handle. I'll say like this. A spanner always has a long handle. So hence, a small force, hence, a small force applied at its end, can produce a larger turning effect by applying a smaller force. A spanner always has a long handle. Got it? Hence, a small force applied at its end can produce a large turning effect by applying a smaller force. By applying, can produce small force है ना ये बोलने की जरूरत नहीं है okay language effect okay so this is one more okay these were the examples I hope people understood me here and let me see whether how we go about okay